Welcome to class 12 physics for HSC CBSE LIS students, and this is chapter 11 continuing dual nature of radiation matter. Dual nature of radiation matter, and today the topic is problems from matter waves. More questions from matter waves. In the last class we have seen matter waves and de Broglie equation, its various forms, and today we will do some of the problems from matter waves or problems using de Broglie equation. Matter waves problems, and these are the important formula we have studied in this topic. The relations are the de Broglie wavelength of matter waves. Lambda is h by p, the first equation. The second equation is lambda is h by root of 2 MeV. The third is lambda is root 150 by V angstrom, and the last equation we have written as lambda is h by root of 2m E. So from these equations, one thing is clear: lambda is h by p, h by mv, and when velocity is constant, the wavelength is inversely proportional to mass. And when we see the equation number 2, lambda is h by root of 2 MeV, the meaning is if energy EV is constant, energy of electron or proton is constant, we say lambda is proportional to 1 by root m. So lambda can be said in two ways. Some cases lambda proportional to 1 by m, and in some other cases lambda proportional to 1 by root m. In any manner we can write depending upon the constancy of velocity and also energy. പറഞ്ഞതിൻ്റെ കാര്യം ഇതാണ്. നമുക്ക് നാല് ഇക്വേഷനാണ് പ്രധാനമായിട്ടും മാറ്റർ വേവ്സിനകത്ത് നമ്മൾ എഴുതിയിരിക്കുന്നത്. ഇതെല്ലാം പഠിക്കണം. ഇതിൽ ഏത് വെച്ചും പ്രോബ്ലം ചോദിക്കാവുന്നതാണ്. ഒരു കാര്യമുള്ളത്, ഈ പി എന്നുള്ളത് എം ബി ആണ്. അപ്പോൾ ലാംഡ ഇൻവേഴ്സ്ലി പ്രൊപ്പോർഷണൽ ടു മാസ് എന്ന് പറയാം. എന്നാൽ രണ്ടാമത്തെ ഇക്വേഷൻ നോക്കുമ്പോൾ അവിടെ റൂട്ട് എം വരുന്നുണ്ട് താഴെ. അപ്പോൾ ലാംഡ ഇൻവേഴ്സ്ലി പ്രൊപ്പോർഷണൽ ടു റൂട്ട് എം എന്നും പറയാം. അപ്പോൾ രണ്ട് തരത്തിലാണ്. വെലോസിറ്റി കോൺസ്റ്റൻ്റ് ആണെങ്കിൽ ലാംഡ മാസിന് ഇൻവേഴ്സ്ലി പ്രൊപ്പോർഷണൽ ആണ്. ഇനി എനർജി ഇ വി കോൺസ്റ്റൻ്റ് ആണെങ്കിൽ ലാംഡ 1 by root m അല്ലെങ്കിൽ റൂട്ട് എമ്മിന് ഇൻവേഴ്സ്ലി പ്രൊപ്പോർഷണൽ ആണ്. And here we begin problems. First problem: a particle is at rest, calculate its de Broglie wavelength. A particle is at rest, calculate its de Broglie wavelength. That is the question, first question. Solution: lambda is h by p, h by mv. The particle is at rest, given v is equal to 0. Since at rest, therefore lambda is h by 0. H by 0 is infinity. You know, any number by 0 is infinity. Here the answer is infinity. Next problem. The velocity of a body is 1 meter per second and mass is 1 kilogram. Calculate the de Broglie wavelength. Velocity is given, mass is given, we have to find de Broglie wavelength. ഒരു വസ്തുവിൻ്റെ വെലോസിറ്റി 1 meter per second ആണ്, മാസ് 1 kg ആണ്, 1 kilogram ആണ്. Find de Broglie wavelength. Lambda is h by p equal to h by mv equal to, put the value of h, 6.626 into 10 raised to minus 34, and m and v are 1 into 1. So the answer is 6.626 into 10 raised to minus 34 meter. You know, wavelength we measure in meter. Wavelength we measure in meter. Remember. Next question: what is the de Broglie wavelength of an electron moving with the 1 by 20th the velocity of light? Light speed in 1 by 20th particle പോയാൽ എന്താണ് de Broglie wavelength? M is 9.1 electron ആണ്. അപ്പോൾ mass is 9.1 into 10 raised to minus 32 kilogram. Velocity is 1 by 20 c. 1 by 20 c, സിയുടെ 20 that is 1 by 20 into 3 into 10 raised to 8. That is the value of c, equal to 1.5 into 10 raised to 7 meter per second. You put the values in the equation, we get lambda is h by p, h by mv equal to 6.626 into 10 raised to minus 34 by 9.1 into 10 raised to minus 31 into velocity 1.5 into 10 raised to 7. On calculation, we get 4.85 into 10 raised to minus 12 meter. Minus 11 meter. This is minus 11 meter. Next problem. Calculate the d-bray wavelength of an electron accelerated under a potential 150 volt. Electron ഒരു particular formula ഉണ്ടല്ലോ. Calculate the d-bray wavelength of an electron accelerated under a potential of 150 volt. You directly apply the formula. Lambda is root of 150 by V angstrom or 12.25 by root V angstrom. Root of 150 is 12.25. So the answer is root of 150 by 150 angstrom. That is 1. Root of 1 angstrom. Answer. Next problem. Calculate the d-bray wavelength of an electron accelerated under a potential 50 volt. Similar problem. Lambda is root of 150 by V angstrom. Put to 150, we get a root 3. Lambda is root 3, 1.732 or 73 angstrom. 1.73 angstrom. Next problem. Calculate the wavelength associated with a thermal neutron of energy 0.025 eV. What is thermal neutron? A neutron which is in equilibrium with the surrounding temperature. A neutron which is in equilibrium, thermal equilibrium with the surrounding is called thermal neutron. Calculate the wavelength associated with a thermal neutron of energy 0.025 eV. You understood the meaning of thermal neutron? A neutron which is in equilibrium with the thermal equilibrium with the surrounding. Lambda is h by root of 2 me. That is h is 6.626 into 10 raised to minus 34 joules second. M is mass of neutron. Mass of neutron is not given. You have to assume 1.672 into 10 raised to minus 27 kilogram. It is almost equal to proton mass. Proton mass we write as 1.67 into 10 raised to minus 27 and a neutron mass we write as 1.672, a slight variation. Neutron mass is a little higher than proton mass. E is equal to 0.025 equal to 0.025 into 1.6 into 10 raised to minus 19. Lambda is h by root of 2me. 6.626 into 10 raised to minus 34 by root of 2 into 1.672 into 10 raised to minus 27 into 0.025 into 1.6 into 10 raised to minus 19 equal 1.81 into 10 raised to minus 10 meter. That we convert into angstrom, 1.81 angstrom. Next problem. Calculate the energy of a neutron if its wavelength is 1 angstrom. So wavelength is given, we have to find energy. Reverse problem. Lambda is h by root of 2me squaring. Lambda square is h square by 2me. So we find an equation for energy. Energy day equation നമ്മൾ എഴുതണം. E is equal to h square by 2 of lambda square. Put the values. H is 6.626 into 10 raised to minus 34 the whole square by 2 into m. Neutron mass 1.672 into 10 raised to minus 27 into lambda. Lambda is given 1 angstrom, which is 10 raised to minus 10 meter, the square. So E is equal to 1.312 into 10 raised to minus 20 joule. That we convert into EV by dividing it by 1.6 into 10 raised to minus 19. We get 0.082 EV. That is the answer. Problem number 8. This is actually not a problem. It is a short answer question. Can be asked as a problem with the details. Electron and proton are moving with the same speed, which will have more wavelength. De Broglie wavelength. ഇലക്ട്രോണും പ്രോട്ടോണിനും ഒരേ സ്പീഡാണ്. ഏതിനാണ് ഡി ബ്രോയ് വേവ് ലെങ്ത് കൂടുതൽ? ഇപ്പോൾ സ്പീഡാണ് തന്നിരിക്കുന്നത്. സിൻസ് ദ വേവ് ലെങ്ത് ഈസ് ഇൻവേഴ്സലി പ്രൊപ്പോർഷണൽ സ്ക്വയർ റൂട്ട് ഓഫ് ദി മാസ് ഓഫ് ദി ബോഡി. അങ്ങനെ എഴുതാം. അല്ലെങ്കിൽ ഇൻവേഴ്സലി പ്രൊപ്പോർഷണൽ മാസ്, സെയിം സ്പീഡ് ആകുമ്പോൾ ഇൻവേഴ്സലി പ്രൊപ്പോർഷണൽ ടു മാസ് എഴുതാം. സ്ക്വയർ റൂട്ട് വേണമെന്നില്ല. ലാംഡ ഇസ് എച്ച് ബൈ എം വി എന്ന് പറയുമ്പോൾ ലാംഡ ഇൻവേഴ്സലി പ്രൊപ്പോർഷണൽ ടു വി എന്ന് മതി. പ്രൊപ്പോർഷൻ 1/m എന്ന് മതി. ഇനി നേരെ മറിച്ച് നമ്മൾ 1/√2 MEV പറയുകയാണെങ്കിൽ, എനർജി പറയുകയാണെങ്കിൽ നമ്മൾ പറയും ലാംഡ പ്രൊപ്പോർഷണൽ 1/√m എന്ന് പറയും. ആ സെൻസിലാണ് ഇവിടെ നമ്മൾ ആ ലൈൻ എഴുതിയിരിക്കുന്നത്. പക്ഷെ ഇവിടെ സ്പീഡ് കോൺസ്റ്റന്റ് പറഞ്ഞതുകൊണ്ട് നമുക്ക് ഇങ്ങനെ പറയാം, ദി ഡി ബ്രോയ് വേവ് ലെങ്ത് ഈസ് ഇൻവേഴ്സലി പ്രൊപ്പോർഷണൽ ടു മാസ് ഓർ ലാംഡ പ്രൊപ്പോർഷണൽ 1/m. സോ ഇലക്ട്രോൺസ് ബീങ് ലൈറ്റർ വിൽ ഹാവ് മോർ വേവ് ലെങ്ത്. ഇലക്ട്രോൺ ലൈറ്ററാണ്, ഭാരക്കുറവാണ്. ലാംഡ ഇൻവേഴ്സലി പ്രൊപ്പോർഷണൽ ടു മാസ് ആണ്. അതുകൊണ്ട് ഇലക്ട്രോൺസ് ബീങ് ലൈറ്റർ വിൽ ഹാവ് മോർ വേവ് ലെങ്ത്. ദാറ്റ് ഈസ് ദി ആൻസർ. ഇലക്ട്രോണാണ് വേവ് ലെങ്ത് കൂടുതൽ. Next problem. Calculate the de Broglie wavelength of an electron having a kinetic energy of 1000 dV. Compare the result with the wavelength of X-rays having the same energy. Calculate the de Broglie wavelength of an electron having a kinetic energy of 1000 dV. 1000 dV kinetic energy ഉള്ള ഒരു ഇലക്ട്രോണിൻ്റെ de Broglie wavelength കാരണം compare the result with the wavelength of X-rays having the same velocity. So electron energy is 1000 dV. The corresponding potential is 1000 volt. You know, when an electron is accelerated under a potential 1 volt, energy is 1 eV. Here 1000 eV is energy. The meaning is 1000 volt is applied. So lambda is root 150 by V. V is 1000 volt. So you put the value, we get lambda is 0.39 angstrom. Say lambda 1. We have a comparison. So this first wavelength we write as lambda 1. And now we go to the case of X-rays. X-rays. You know, X-ray radiation. It is a photon. The energy we write as E is hnu, h2c by lambda. So lambda is hc by E. Put the values. 6.626 into 10 raised to minus 34 into 3 into 10 raised to 8 by 1000 into 1.6 into 10 raised to minus 19. Energy that we write in joule. We get to 12.42 into 10 raised to minus 10 meter. 12.42 angstrom. Say lambda 2. So lambda 2 is large. So comparison we do by dividing lambda 2 by lambda 1. Lambda 2 by lambda 1 is equal to 12.42 by 0.39 equal to 31.85. If you find lambda 1 by lambda 2, if you find lambda 1 by lambda 2, that is no problem. In that case, the answer will be less than 1. Here we have determined lambda 2 by lambda 1. You can also find lambda 1 by lambda 2. Next problem. Evaluate the ratio of the de Broglie wavelength of electron to that proton when both have the same kinetic energy. B. The electron kinetic energy is 1000 eV and that proton is 100 eV. രണ്ട് പ്രോബ്ലമാണ്. ഇലക്ട്രോണിൻ്റെയും പ്രോട്ടോണിൻ്റെയും വേവ് ലെങ്ത് കമ്പയർ ചെയ്യുക രണ്ട് ഡിഫറെൻറ്റ് കേസിൽ. Electron and proton with the same energy. So we use the equation lambda is h by root of 2m eV. is constant. So therefore, for electron we write lambda 1 h by root of 2 m1e, equation number 1. For proton lambda 2 h by root of 2 m2e, divide 1 by 2. Energy is constant. We get lambda 1 by lambda 2 is root of m2 by m1. m1 is the mass of electron, m2 is the mass of proton, and you remember mass of proton is 1840 times the mass of electron. So if electron mass is m, the proton mass is 1840 m. So root of 1840 m by m cancel. Root of 1840 equal to 42.89. Answer. And next part is electron energy and proton energy are given separately. Electron energy 1000 dV. So here we have to put 1000 dV energy, or we can write in the manner root 150 by 1000, or energy you convert into EV and calculate. That will need some calculation. So here lambda is 0.39 angstrom. It can be done by taking the formula root of 150 by V angstrom, V 1000. On calculation we get to 0.39 angstrom. Proton energy 100 dV. Lambda h by root of 2m e, we have to convert 100 into joule and substitute. We get 0.0286 angstrom. So here also lambda 2 by lambda 1. That is 0.39 by 0.0286. That is 13.64. That you know, electron has higher wavelength. Another question. What is the velocity in meter per second of a 0.179 kilogram billiard ball if its wavelength is 7.8 centimeter, large enough for it to interfere with other billiard balls? What is the velocity in meter per second of a 0.179 kg billiard ball if its wavelength is 7.8 centimeter? Answer. Use the expression for the billiard ball's momentum in the equation. That is lambda is h by mv. Another above equation, the equation is below. H by mv. Substitute the value of Planck's constant, mass, and wavelength in the above equation. We get 0.083. That is, wavelength in centimeter is converted into meter by dividing it by 100. Equals 0.626 into 10 raised to minus 34 by 1.179 kilogram. The unit is written into velocity. Unit is not required. That is 37.0176 into 10 raised to minus 34 by 0.0783. That is velocity. That is V is equal to 472.556 meter per second is the answer. 472.556 meter second raised to minus 1. That is the answer. I think everything is clear. You need not write the unit in steps. Only at the end. You need only write the unit at the end of the question. That is solved with your 57th class on radiation and matter, double nature of radiation and matter, and we continue our class with atoms and nuclei. Thank you very much.